So in this video, we're just going to work with a variety of rational functions and just work on making sure we understand how to know if there are horizontal asymptotes and how we would write that work out well. So there's a series of instructions here. For each one, we want to figure out what our model is going to be for end behavior, then just evaluate that, and then decide if we do end up with something that's kind of unique on the ends of this graph. So for this first one, 2x plus 5 all divided by 3x squared minus 6x plus 1. For the first little piece there, what's the end behavior model? That's going to be, let's see, EBM for end behavior model. We just take the largest chunk in the numerator, so 2x, and we're going to divide that by the largest chunk in the denominator, so 3x squared, and that's going to reduce to 2 over 3x. Okay, so that is our end behavior model. For part 2, okay, that now evaluate the limit. Well, we're using this to tell us what's going on at infinity. So we're just going to look at the limit as x approaches infinity of this end behavior model. Now remember, I only need to worry about infinity at this point, because if we find a horizontal asymptote on the right side, it's got to be the same thing on the left side for a rational function. This is something that if I think about plugging bigger and bigger and bigger numbers into that denominator, into that x in the denominator, it's going to start shrinking. It's going to get close to 0. Okay, so we've evaluated the limit. Okay, and now step 3, is there going to be a horizontal asymptote? Yes, there is, because of our end behavior model. So we'd say yes, there is one, and it's going to be at y equals 0, and that's going to be on the left and the right side. Okay, for our second example, go through the same process. Okay, our end behavior model is going to be 2x squared over an x squared, and that's just going to reduce to 2. Okay, so some of this gets a little redundant, but we want to evaluate that limit. So the limit as x approaches infinity of the idea of 2, well, there's really nothing to plug in there. It's just consistently 2, so that's also going to get us a nice answer. So what's going on with the end behavior? We'd say yes, there is a horizontal asymptote, and it is y equals 2. So that one's not so bad. Okay, and then our third one, what's our end behavior model going to be? So first, end behavior model is going to be x to the 4th over 3x. This one's a little messier perhaps, but an x on top will cancel out with the x on the bottom, so we have x cubed over 3, which we could also say is 1/3 x cubed. Okay, for our second one, evaluate the limit. So what's the limit as x approaches infinity of this end behavior model? So 1/3 x cubed. Okay, well, that's, if I plug in really big numbers there, it's just going to keep getting bigger. So that limit idea goes to infinity. So that means there is no horizontal asymptote. But we could be a little bit more specific. I could write this in limit notation if I wanted to. I could also just say, I know based on that end behavior model that as we go to the right side, y is going to go up. So y is going to infinity. And in this case, we'd also want to think about going to the left side. So as we approach negative infinity, y is going to, really I probably shouldn't have done equal symbol here. Maybe we'll do an arrow. Okay, it's going to go to negative infinity as well. And we know that because of our end behavior model. We know what something like x cubed should do. It's going to go up on the right side, down on the left side. So again, we've done all of this before. We're just maybe writing our work, showing our work in a little bit more of a specific way.